Let's get started here at the NVIDIA booth, the GDC Technology Theater. We're going to get started with Russ Kirshner from NVIDIA. He's going to talk about DirectX profiling with Parallel Nsight. Take it away.
Thank you. Okay, yeah, so in case you're not familiar with Parallel Nsight at all, this is currently a Windows tool. In terms of graphics, we support DirectX 10, DirectX 11, and also some profiling features for OpenGL. So much of what I talk about right here is going to apply to OpenGL as well as DirectX. But our idea here with Parallel Nsight, we want to parallelize the whole development process. So you're in one environment for your CPU code as well as your GPU development. And Parallel Nsight has three main portions. The first one that I actually demoed on Wednesday is the GPU debugger. This allows you to set breakpoints and run pixel histories within your application. The graphics inspector, which is similar to PerfHUD, and then system analysis, which is what we're going to cover today. Okay, in terms of environments or platforms that you can run this on, actually, all of the analysis features can be run just on the host and the target on one machine. Okay, so you only need one GPU, one box, and Visual Studio, and your target application, and you're good to go. Okay, another configuration that is very common for Visual Studio is to actually have two computers. So you're going to be doing all of your GUI sort of analysis on your host app, on your host machine, and that's going to be running Visual Studio. And then your target machine is going to be communicating over TCP/IP. And the target is going to collect all of the data to send to the host. Okay, and this is our fancy box that we support. This is called SlyMOS, just like Sly and then multi-OS. Basically, we run through Parallels. You can run a virtual OS. And what happens is the second GPU in the system gets, we have a special slave driver that will allow Parallels to access that GPU. And so you can run the second OS with the fully supported GPU. Okay, this is a list of features which is new. I'm going to focus on the analysis features since that's what we're talking about today. So now we've got the ability to save and restore profiler sessions, so you can write out to disk and get all of your data back for an offline analysis session. We have full call stack trace now, so if you provide symbols to us, then we can show you precisely where an API call came from in terms of your application in the call stack. We have trace workload correlation. That means that if you have a GPU event, like a draw call that's actually executing on the GPU, and we trace that, you can click on that and then get full information for the API that spawned that call. And again, go back to the call stack if you want to. So add some overhead improvements, and also a system information page for analysis. Okay, so I'm going to show you first of all what we give you on the target side. This is like a very PerfHUD-like environment. However, I'm not going to go into frame debugging today. I'm just going to talk about the performance graphs because these can give you a very nice first pass in terms of what is my performance and why is my performance that way. So starting out, I've got the GPU idle counter up there at the top. That's kind of our most basic common counter that we'll default to. And within the HUD, you can move that around and resize it. However, this GPU idle is very low. It seems like we're very bound by the GPU, so we can get more detailed information if we go into the HUD configuration and pick out some more signals that will give us a little bit more detail. Okay, so I'll just go ahead and name that for clarity for myself. And I'm going to create a second graph. We have several graph types. We've got raw signals, which basically it is what it sounds like. You can have just raw values that can go from 0 to infinity, and then normalized values that are just going to be a percentage. So normally these idle and busy counters are going to be a percentage, so that's the kind of graph that we create. And let me pick out 4 of the most interesting units. Okay, and I can change the colors if I want to. I can rename the graph, and we give you by default a choice between a line graph and a stack, where all of the values will be stacked on top of each other, depending on what's an easier visualization for you. Okay, so that looks pretty good. Going to do a line graph and rename this one. Now, so we have these generic graphs where you can just grab all the generic signals that you want, and there's hundreds of them. And we also have these hard-baked graphs. We've got the FPS because everybody wants to see that in some form or another. And then we've also got like the batch histogram. That's going to show you. It's just a histogram of the number of primitives per draw call. All right, so we've got all of our graphs configured the way we want now. And I'll just go back to the HUD, I believe. And you can see how that pops up. We just put all the graphs in a default location. However, if you drag these over, then the nice thing is, you only set them up once, and then we'll save all the positions and colors and everything. So the next time you won't have to do all this work. Okay, and we can see that, wow, the shader busy unit, that's really high. So it seems that we're pretty shader limited. So I'm going to show you a few ways to approach that and figure out how we can optimize the application and get that down to a lower level. Oops. Okay, I'm going to show you on the Visual Studio side how we actually launch things. So what happens by default is we're going to pull in your launch settings from your C++ project itself. However, from here we can customize things. In order to create the job, so the first thing is we're going to go over to the project itself and hopefully get a Visual Studio icon. Sorry about that. Okay, the video appears to be stuck. But so basically, you're going to go over into the Nsight menu and say, create a new analysis job. That's going to pull your project launch settings, and you'll be able to decide whether or not you'll be able to decide whether you want to start the profiler immediately or later on. You can decide whether you want to show call stack traces. You can pick out your API region. So you say, I want to trace all of DirectX or all of OpenGL. You can decide that you want to pull system information, like how busy are each of the cores. So all of that was all in the launch settings, and I'm sorry that I didn't get to show you that. Okay, so after so now I've captured the analysis job, and what you can see is you've got all the basic launch settings up there at the top, and you've also got the files that were captured as output files. Okay, so basically we serialize everything into this NV report down there in the middle, and that's the file that you can open up later in Visual Studio, and you'll be able to see this job again, on a different machine. You could save up 20 of these analysis reports and compare them later for offline use. Okay, down there we have all our launch information and our interesting thread ID, all of that. Also, so there's several ways to look at the data. However, the kind of core key one is the timeline. So I'm going to jump straight to that. Okay, so this is what the timeline looks like, completely collapsed. I elected to capture system information globally, and so you can see all of the processes that are running on the system right now. And if you just drill down for a second, what you can see pretty quickly is that most of them aren't doing much other than our key process. So that's probably a good thing. But you can see from the color coding that this is waiting right now. So that thread's not doing much. it's only for this very small window is the actually getting a time slice. So since we're probably not interested in all of these extraneous threads, what I could do is I can set up a filter and say, this is my process ID. Let's stick to that. And so now we only have crisis 2. Okay, and that main view, you can see right there how busy the whole process is keeping the system. And we can also drill down and get all of the threads within crisis 2. You can see that there's only 2 or 3 threads that are really doing a whole lot. And as I mouse over them, I can get the thread state, which is mostly running. So I'm going to set another filter just to only get the threads in crisis 2 that I'm really interested in. And I say the core must be at least 10% occupied or greater. And you can see that knocks out all but 3. And as it turns out, most of my interesting events that I'm interested in are in the second thread. So I'm going to open that up. And you can see that we've got API level profiling. So we've got all those individual events. Got a big unmap call at the start. I think that was actually some overhead due to the profiler that we need to eliminate. But one thing we tell a lot of developers is that it's really great if you can instrument your application with perf markers. It's just the D3D9 API, and all you do is you say begin perf marker, then later on end perf marker. You give it a color and a name, and this allows you at a glance to see, generally what was my application doing at this point. And we use this not only in the profiler but also in the frame debugger and the frame timings tool that I'm going to show you a little bit later. So that's a really great way to navigate your application. And these all have timestamps, so you can write that down and easily get back to a particular event. And you can use these to measure the duration of a group of calls within your analysis trace. Okay, really slick resizing controls that they've implemented. So you can see that here we're on the function call list, and what's kind of cool that we've added recently is this context menu down below. So since I've clicked on the function call list and I've selected a particular draw call, I can get all kinds of metadata about it, but kind of the most exciting that's new is the call stack. So you can trace all the way back to your application very easily and understand exactly what that activity was on your profile. Okay, and so the next level of information is DX-specific tracing that we've added. A lot of this correlates to what's on the thread above. However, we're focusing mostly on draw calls and copies and those types of interesting events. And what you can see right now is we've got the frames at 2 levels. We've got the CPU frame, and then right below it, the GPU frame. And so the CPU frame is just present call to present call, as you'd imagine. And then the GPU frame, we're actually tracing that on the GPU through the command buffers. So you can get instant readout of how much overlap do I have, and maybe you want to learn how to improve that a little bit. So again, this is the API call stream that says draw indexed, and right below it we have actually the GPU events. And the bigger block on top right there, that is the command buffer. That's actually executing on the GPU, passed to us through Vista or Win7. And you can see here how much of your time was occupied by these command buffers. Typically, you want to make that as large a percentage as possible so that you're keeping your GPU busy. And you can also see the constituent draw calls that make up that command buffer down below. Let me resize everything. And these have IDs, draw call ID that correlates to an API call. So you could do it manually if you want. However, we've got the nifty context menu down below. This is going to show me for the location of the cursor, what are all the draw calls. And I can find one that I'm interested in and read metadata. And another new feature, this is going to have that link right back to the API call. So you can literally just find an event on the GPU and trace that all the way back your call stack, and see what's going on in the application at the time. Okay, so the timeline was the primary way of looking at that data, but it's not the only way. As you can imagine, it might be more useful in some cases to have a grid view. And so here's an example that we provide. We have several different grids, but this one is the DirectX API call summary. And what this does is just, as you can see, it provides a really quick and dirty summary of all the classifications of draw calls, or of API calls rather. And that's all sortable and filterable. As you can see, that this actually creates a more detailed view down below with a complete list of all of that type of call. And so it becomes more specific than just the draw call. You can see draw indexed or whatever. And also, it seems like unmap is taking up a large portion of our list, and so you can find the unmap call, which is the most expensive, and the timestamps, and then that correlates back into the timeline, and you'll be able to correlate that way. One thing that's kind of cool with the filter feature, obviously you can just use this to filter, but I also like this because you can find all of the discrete values that occur down in your column. So let's say I want to know, are there actually multiple threads which are rendering these DirectX API calls, and I can say no. I can see that everything absolutely is on this thread. So that could be a good way to make sure you don't have a problem there. Okay, kind of expanding on this list are DirectX API calls. This is just a flat global list of all the events that we traced in DirectX. And again, we can filter by any column. It's completely generic. All of these controls work exactly the same way. And we can find the duration, or again, you can find a particular call that you're interested in and get the stack trace. So they've sent this all over the API or the UI. The third view is kind of useful. Often you just don't care about the API calls immediately. You want to know how much did my entire frame take up. And so again, here's a flat list. It's got the start and end times for all of the frames. And again, we show both the GPU and CPU frame information, so you can quickly compare those and see how they line up, and see what kind of overlap you're getting between the two. Okay, and again, here's the command buffer duration. This is another way of viewing it. Higher is better in general. We want that the command buffers to take up a large portion of our frame time. So that's something you can optimize for. Okay, also we have this neat view of perf markers. Over on the target side, we have those bars to show you what perf markers are per a particular draw call. However, here we have this indentation per levels of perf markers and the names, and so you can traverse the list of information that way if you choose to. Okay, so I've talked a lot about analysis jobs right now. Now we have some other ways to focus in on performance from the frame debugger side. So what I'm going to do is close out that analysis job, and Now, just like before, I said that my launch settings are in the Visual Studio project itself. So I can count on the app startup and the launch path and the parameters. That's all just going to be part of the project over here. I can open that up. And if I select that project, then I can see that, okay, yeah, there's the external program that I want to launch and the external target machine. Okay, so I say start graphics debugging. This is going to launch on the target side with just some injected instrumentation for every API call. And after the application's where we want, I say pause and capture frame. That brings up the frames page with the perf markers. And this is what Crisis 2 is going to look like. As you can see, I showed you the graphs. But right now, okay, so I've captured it, and I've got an entire frame's worth of events, and the perf markers down there on that frame above. So now that I have these captured events, I can go ahead and do some analysis on them. Okay, so this is the host again, and there's the frames page, and I can go over to profile frame. Now, what this is going to do is it's going to loop through the frame many times over, each time setting a different performance experiment, trying to determine bottlenecks and utilization. And this is cool because it helps you very quickly identify which units are the most busy in your application. And not only that, but find which draw calls are contributing to the bottleneck and utilization the most. You can see right off, overall for the entire frame, it's going to be the shader unit, 18 and 43% utilization and bottleneck respectively. And that's for all events on the frame. Of course, that can be a lot to bite off immediately to say, okay, I want to optimize the whole frame. It's better to kind of focus on a few things. So I'm going to show you that in a moment. Just quickly, utilization means what you would expect. How often is this unit busy out of 100%, out of any given time? Whereas the bottleneck means, how much time did this unit block the unit before it, or was it starving the unit afterwards? Okay, and we also have these wait bys. Looking at this unweighted is going to be a little bit deceptive because you could have a single draw call with an extremely high bottleneck on the raster operations, but actually that draw call isn't so important in the entire frame. So normally the GPU time is the most accurate weight for these things. However, you could also weight by pixels or primitives, and you can see that if you select primitives, then you're going to be more bound by the input assembly, or pixels is going to be more bound in the frame buffer. Okay, so we'll go back to GPU time. Now, like I said, this is a global measurement for all draw calls. And it might be more interesting to know, okay, let's limit these and find the most expensive draw calls and group them together so I can really optimize my application. Okay, and so one common way that we had in PerfHUD, and we carried this over, we've got state buckets. So you can say, group together all my draw calls according to some piece of state which is interesting to me. And I might say, okay, since I already know that this is a shader-limited application in general, I want to look at the pixel shader. Okay, so here we have under state buckets, that's a big list of all the pixel shaders, essentially, and all the API calls that are associated with that. Okay, so I can look at a particular, this seems to be the most expensive pixel shader, and I can click on that, and over on the right, that's going to be populated with all the draw calls that fall under that pixel shader. And instantly under my summary, I can see how that affects it and say, yeah, this one does appear to be really shader limited, so let's go directly to that pixel shader and optimize it. See an immediate performance impact. Okay, so I'm going to turn off the bucketization and show you another way that you can create buckets of events. It's using our friends the perf markers again. And that gives you, as the developer, a lot of control over which events you want to group together. So options, add perf marker group, and there you can see your entire scene again. and let's say I'm interested in the shadow pass and this general AW perf marker, then that gets looped in, and under state buckets now I have this perf marker, or above it I have a perf marker base group, and I can do my comparisons there just like I did with the state buckets based on the API. Okay, and then, okay, wow, this one is really shader bottlenecks, so that's a good perf marker to start with. Okay, similarly, we've also got bottleneck percentages. This is we just had the summary view of how bottlenecked we are per unit. This is going to break it down by all the draw calls in that group, whether we be the global group or the perf marker group. So that gives you a really nice way to traverse, and you can see in the graph instantly, okay, this is something I really need to focus on. Okay, a couple other basic graphs, shaded pixels and primitives also. That information might be useful to you. Okay, related to the frame profiler, we kind of got the feedback that the frame profiler is great, but sometimes people just want to get very quick timings for their GPU calls. They want to see what a draws cost, and that's all they're really interested in. And so we kind of wanted to optimize for that use case, and we created the frame timings page. And okay, again, the first good thing about the frame timings page is that it runs almost instantaneously, because we only have to loop through a single playback of the execution. Okay, so that was real time. That comes up like that. And over on the right-hand side, you can see we provide 3 different ways to measure the timing of your draw call. We've got the full pipe cost, which is down on the lower left. That essentially shows you the parallelized real-time cost of all of your draw calls. Okay, and so that's interesting to see. It can be a little bit misleading as a measurement of which draw call do I need to focus on optimizing, because you've got this overlap, because you don't really know which draw call is putting the most stress on your GPU just from that. So we have this other more basic timing, which is just going to measure the cost of a draw call in isolation on your GPU. It's saying if this GPU gets flushed before and after the draw call, how much time is that going to take us? And that tends to be a very good criteria to sort your draw calls and decide what's the most expensive. We also have the incremental cost, which essentially says, what's the tail end of the parallelized full pipe cost. It's saying what part of this draw call was unique, or what part of the cost was unique to this draw call, and kind of ignores overlapping draw calls before. And actually, the incremental cost and the empty pipe cost tend to be similar, as it turns out. Okay, again, we have all of our nice WPF Visual Studio controls, completely sortable. You can select a range of draw calls, like say in the data grid, and that will show up highlighted down on the graph on the left and the graph on the lower right. Everything is synchronized, and everything plays together, so you can get multiple ways to view this data. Also, with the perf markers, you can click directly on the perf markers or multi-select them or span select them, and just quickly see what are the timings that you're interested in, and in that way you get a very good idea of the cost of a particular perf marker visually that way. Okay, so that kind of concludes it. Parallel Nsight is a free download. You just have to register on the developer page. So I hope that you'll all try it. Okay.